This is an extra explanation for exercise 14.2. I'm looking at some questions in the A exercise where we're applying the knowledge. This is quite a nice one here where we're looking at different graphs and using what we know about equations of graphs to pick out which they are. And the next one's a really important skill about finding where points meet. So it shouldn't be too long because I'm just doing these two questions. If we look at all these equations, we've got 1, 2, 3, 4 linear equations. So 4 where we haven't got any x squareds in them. We've got 1, 2, 3 quadratic equations. And that matches up with what I've got here. Now, if we start looking for negative gradients on the linear lines, that one there is the only negative. So the only negative gradient in a linear equation is this one here. You've got minus x, that negative gradient. So this one here is C. So C, the answer for C is to pick out the line E. That's what you should see in the back of the textbook. Now if we look at the straight lines going up, where we've got positive gradients, these two here, so that looks to be like B and F, they're parallel. So let's see if we can find two equations where we've got the same number of x's, so that will give me the same gradient to make them parallel. But here we go, we've got a 2x here and a 2x here, so these two lines are parallel. Now look at the intercepts, plus 3, minus 2. So this one is going to be lower down, because it's going to cross the y-axis lower down, because its intercept is minus 2. So F must be what the answer is for B, and the other one which we said, or I'm saying, is C, is the answer for A. Okay, that only leaves us one more straight line, that one there. So that must be a gradient that is less than 2. If we look through there, we've got a half x. So that's a smaller gradient going through at minus 4, so that fits in, it's going down a little bit lower. Now that just leaves us with 1, 2, 3 quadratic graphs to look at. You can see this one here, A, is upside down. So that's going to tell me that I've got a minus x squared, and the only one with minus x squared is this one here. So for E, the answer is going to be A, because it's the only quadratic graph with a minus x squared, which flips it over. We've just got these two to solve now. These are the two quadratics that are left. So we've got x squared plus 1 and x squared minus 10x plus 21. I think the easiest way to look at these are these two intercepts. These work just like they do on linear graphs. So the one that is higher up is going to be this one, 21. So I would say that this one here, which is the equation D, or the graph D, goes with F, which only leaves us that one there, G, which must go with this one because it's crossing lower down, plus 1 less than plus 21. Okay, make sure you look at those and understand why those various equations go with those graphs. I'm now going to move on to question 8. This is a really important skill, comes up a lot in exams, about knowing where lines cross. I have put in a wrong answer to start with, because some of you might look at this and think, well, if that's minus 1, this point here is the same distance above the line, so that must be plus 1. Well, if I know that y is plus 1, what I put here, I can put that in the equation. It's given me enough information, because because it tells me the linear graph is a gradient of 2, so 2x, and it's showing me that it goes through at -1. So this equation is right. Y is equal to 2x minus 1. And if I assume that this point is 1, because it's the same distance above as it is below, then I can put y equals 1 into that. So 1 equals 2x minus 1, swap that around. Minus 1 goes over to here to give me 2. 2 is equal to 2x, hence x is equal to 1. So I get the point that p is 1, 1. Well, that is not actually the correct answer. This is a sketch, and the scale is really awful. If you did a sketch like this in the exam, you wouldn't get any marks because it's way out. So a sketch, whilst it is not 100% completely perfect, it still needs to be fairly accurate. One of the reasons I know this is not accurate is because if we look at the gradient being 1, and I go across 1, I go up 2, but I don't. This is 1.5 squares. So they've drawn this graph out. So this isn't actually the point y equals 1, which is why this method doesn't work. Although it's a good example of a question, I don't know the way they set it up, because it would be very easy to make the mistake of thinking that's the way to do it. We're using a real classic technique of when I know the equation of that straight line that I got from the first part, 2x minus 1, I put that equation equal to this equation, because where the two equations are equal gives me the 2 points where they meet. That might make a bit more sense now. We think about when we solve quadratic equations, we sometimes get two answers. Sometimes it's because of the two roots, two places where it goes through here. Sometimes it's because you get a straight line that crosses it twice, and that's why we get two answers. And the two answers invariably come from the fact that x squared can be a positive or a negative. Anyway, when I put the equations each to the other, I've got this whole thing here. The first equation for the straight line is equal to the equation for the quadratic. I can swap that over. The minus 1 becomes a plus 1 over to here, so that actually gets rid of that, because minus 1 plus 1 is 0. 2x comes over and becomes minus 2x, so I actually have minus x, take away another 2x, so I have minus 3x. So I get this equation, should be a squared there, excuse me, 2x squared minus 3x. I can then factorise that. X comes out because this should be an x squared. X times 2x will give me that x squared. X times minus 3 gives me that minus 3x. So this is where I've now got my two solutions. X is 0 because 0 times this will give me that answer 0 that I wanted. To make this bracket 0, this will have to be equal to plus 3, because 3 take away 3 is nothing. Then nothing times whatever that is will give me the 0 that I want. For x to be making this whole bracket equal, a half of x is going to be the same as that half of 3. So x is actually 3 over 2. 3 over 2, and then you can get the y value that goes with that by putting 3 over 2 into either of these equations. Personally, I put it in the linear equation, that's easier. So 3 over 2 times by 2 becomes 3, take away 1, give you the answer 2. So these are my 2 points that work. 0 minus 1, because when I put that 0 answer in here, into this one here, 2 lots of 0 minus 1 gives me minus 1. So 0 minus 1 is what I already had here. One solution when they cross, and 3 over 2, 2 is that point there. So that y is equal to 2. So the sketch they put here is way out of scale, and I think really they should have said that to make it more obvious the way to do it. But this, as I say, is a classic technique of how to do some exam questions. Apologies for not putting the squared in there. I will put it in before I upload this PowerPoint. So looking back, I noticed that one of the earlier videos, I read a question and said y-axis instead of x-axis. but did the working out right. So just look out for that, and hopefully you're paying attention and you will be able to spot my error, which wasn't deliberate. It's just a lot going on when I'm trying to record all of these. Anyway, that's just an explanation of some questions from the A exercise, and hopefully that'll help you do some of these. Take care, see you later, bye bye.